thank you for the opportunity that you've offered learners across the world to actually learn to understand various ways of solving problems using differentiation. Under this topic today, as you have rightly said, we will be considering aspects of differential calculus, specifically the minimum and maximum values of problems. Now, the objective of today's lesson is by the end of the lesson, the learner will be able to apply rules of differentiation in solving problems regarding measurement of perimeter, area, and volumes of 2D and 3D shapes, respectively. Now, so what we're going to be looking at are shapes. But the thing is, before we enter any segment of the session, we need to understand what some terminologies are. For example, what is a two-dimensional shape? What is a three-dimensional shape? And what is a dimension itself? A dimension is the measure of the size of an object, usually given as length, width, and height. In mathematics, the notion of dimension is an extension of the idea that a line is one-dimensional, a plane is two-dimensional, and space is three-dimensional. What is a two-dimensional shape? It is having only two sides, that is length and width, or length and height, or width and height. For example, flat shapes such as circles, triangles, rectangles, squares, and more are all called two-dimensional objects. What about three-dimensional shapes? A 3D shape, as it is called in short, is a solid object that has three sides: length, width, and height. 3D shapes that have depth, it means they can contain other objects, or they have volume. A soccer ball, cylinder, rectangular prism, and more are three-dimensional shapes or 3D shapes. But as you can see in these pictures, which we are not going to spend more time on, in your primary school days, we have a number of shapes that are there. You can see rectangle, square, rhombus, etc. And I know you know this. This is grade 12, so we need to move to the problem-solving aspect. So as we go on, we will look at more shapes and the formulas. So after this lesson, the recorded version will be sent to you either by email or WhatsApp or on YouTube. So you will be able to have more information on the formulae that are here. Now, this is the beauty of mathematics. Every problem you solve is related to shapes. These are the three-dimensional shapes. As you can see, you can move around them. You can see the height, the length, and the width. As you know, many shapes are here, which you know: the cylinder, the cone, the cube, and the prism. All forms of prism are here. Then the pyramid is part of it. Here are more 3D shapes, which we've seen earlier with the formula. So when we get to the problem solving, we will learn to use all these formulas and try to make use of them. And here we have other more 3D shapes, but as you can see, we have the prism, which is this kind of prism. It's a pyramid. As you can see, this is a pyramid, and this is the next form of the pyramid. And when this is folded, then we form this kind of shape, which is a pyramid. So the pyramid has been taken down into a net form for you to know what exactly is there. As we continue, you will realize that we have more shapes, we have more formulas, we have more information. So later, when the video is put on YouTube, you can download and take your formulas. I'll be explaining more of these formulas. That is why we don't want to spend more time on that. As you can see, we can see the Egyptian pyramid. The reason why I brought this shape here, or this image here, is that the Egyptian pyramid tells you a lot of stories about the shape pyramid which we use in mathematical problem solving. as you know, in the olden days, the pharaohs or the kings of Egypt in the past were, whenever they passed away, this was where they were kept or buried. Now we move to the next stage where we start seeing how to deal with problem solving. So learners, I would like you to pay a critical attention to this diagram. Now, this is our first question. A rectangular box with a square base, x centimeters, and height of 8 centimeters is to be made from a cardboard. Now, what we are looking at is a prism. It is a rectangular prism. But according to the question, the base of this object or this shape is a square. So if the base is a square, obviously you must know that the length of the base is the same as the breadth of the base. For example, if the base, this is the base area. So the base area of a rectangular prism is the same as the lid or the top cover of a rectangular prism. So it may not look like a square here because it is not drawn to scale. But the examiner says the top here is a square. Or if the base is a square, then the top is obviously also a square. So if the base, this one is called the length. If the length is equal to x, since it is a square, this part of it, the breadth, must also be x. So our breadth is the same as the length. That is the meaning of this question. And the height has not been given any numerical value, no value in a number form. So meaning we are going to be using the numerical values as has been given. So take note, the length and the breadth of the base of the prism are the same because the question says the base area is a square or is in square form. All right. So we will now go on to look at how to solve the question that is based on it. Now, the first question. So it says, given that the box holds a volume of 200 centimeters cube, find a formula for h in terms of x. So this is what we're going to do, learners. Remember that this is a rectangular prism. So I have to take note. So let me say, what are the items that I need? I need the length, I need the breadth, I need the height. Now, according to the question, the length is x, but because the base area is a square, the breadth is the same as the length. But the h is still h. So, what are we going to do here? The information in the question is about volume. So then you ask yourself, what is the volume or the formula for finding the volume of a rectangular prism? Now, there are 3 items that make something or a rectangular prism a 3D shape: the length, the breadth, and the height. So when you find a product of that, I mean when you multiply them, you get a volume. Look at it. So volume, okay, volume is equal to the length times the breadth times the height. This is in the formula sheet which you saw earlier, but you don't have to worry. We can always remember it. So let me say V is equal to my length is x times. You know that we can also use a big dot for multiplication in order not to confuse the x with the multiplication sign. And our breadth is also x, but our h remains h because no value of h has been given. Now, when we continue, you will see that we have x times x will give us x to the power of 2, or what people call the x squared, then times h. But the question says, find the formula for h in terms of x. When the question says find the formula for h, it means make h the subject of the formula. If it says in terms of x, what does it mean? In the solution, there must be x value. There must be x, not in a numerical form. All right. So what I can do, first of all, don't panic. So I'll have x squared times h. But because we want to make h the subject of formula, I have to divide both sides of the equation by x squared. Now, what I'm trying to do is I'm finding the inverse operation of multiplication of x squared. So if we divide x squared by x squared, obviously what is left here is h. So reversibly, I can say my h is equal to v over x squared. Now, something is left. The question says the volume of the prism is 200 centimeters cubed. So what I am going to do is to say that my h now is therefore equal to the v, this is the v, the volume. So it will be 200 divided by x squared. Now, learners, this is how to do it. Don't be in a hurry to worry yourself in taking a screenshot and whatever, because we will give you back the video as time goes on. So this is how to work out your solution for that question. Now, come to think of this one. Show that the area of the cardboard. Now, remember, when a cardboard is a prism and they say find the area, it means you are finding the total surface area. That is the meaning. Now, you are to write it in the form of 2x squared plus 800 over x. All right. So don't panic. What you need to do is to remember the formula. Hey, can we remember the formula, learners? Are you there? All right, let's try it. You have surface area, that is SA. I'll use SA as the surface area. Now, so the thing we have to do is that there are two parts of you see the bottom and the top are the same. So we will say 2, and the bottom we know it is length times breadth. Now, why are we multiplying by 2? Because we have two faces that are the same. Then we say we have the other sides. So we can also have length times height. Then we can also have 2. Then we can also have breadth times height. Now take note, I want to tell you something. It doesn't matter the order in which you write them. It is still the same. That is one thing you have to remember. You can write 2 breadth times height first before 2 length times height. You can also write 2 length times breadth at the last position. It doesn't destroy anything. Okay, let us see how it's going to play out. Now, there is an information which we need to bring into the problem solving. Remember that we have, let me put it here so that you can remember. H, in the previous question, H was equal to 200 over x squared. So this very thing, keep it safe because you are going to need it in your problem solving. All right, so let's continue. So I have my surface area is equal to 2 times, what is our length? Remember it. The length is the same as the breadth. That was based on the question that we did earlier. Then here we have 2 times length, which is x, and then times h. Don't panic, something is going to happen. Then we have plus 2, and our breadth is x, and we still have h. Okay. Now, if you look at the whole of this part, 2xh plus 2xh, they are like terms. So we can add the coefficients. 2 plus 2 is 4. Now, so I have SA is equal to 2x squared. Then 2 plus 2 will give us 4. So I have 4. Then I have x, and then I have h. So 2xh plus 2xh can give us 4xh. All right. Very interesting. Look at what is happening. Are you ready, learners? So there is a problem. Remember the question that we are supposed to solve. Look at what is happening in this question. There is no h in the question that we've been asked to, or whatever we've been asked to prove. It means that this h is questionable. We need to remove that h. So what shall we do? We need to substitute something that is equal to h. And that thing is 200 over x squared. So 2x to the power of 2 plus 4. Now 4, we have x, but now we have to multiply it by, and my h is 200, all divided by x to the power of 2. Now I want you to take note of something, learners. I'm not going to rush you through. Remember that when you have a whole number multiplying a fraction or a common fraction, you must make sure that that whole number multiplies the numerator of the second fraction. So what do I mean? Okay, I have surface area is equal to 2x squared. Are you getting it? Then plus 200 times 4 will give us what? Do you remember? Or you have your calculators? It will give us 800, but there is another x there. All divided by x squared. I want to do it like a primary school learner so that you can follow. This x squared, are you getting it? X squared is equal to x times x. So therefore I can break it down so that you can see properly that when we divide this x by x, the denominator is going to be left with another 1x. So if that happens, then obviously you are going to have SA, which is surface area, is equal to 2x to the power of 2 plus 800 all divided by x. Now, you see that one question leads to the other. The first question leads to this. And now what is going to happen is that you need to be patient. I'm trying to break it down. You won't find them in your textbooks like that. We are making it self-explanatory for you. So that is how you work it out. And take note of that solution because we are going to make use of it in the next stage. Now, the most critical question which you can find is when they are now talking about lists or when they are now talking about maximum or minimum. So remember, when they say maximum, it means the first derivative of the function is equal to 0. And when they say minimum, it means the first derivative is equal to 0. When they say most simply means the first derivative is equal to 0. And when they say least also means the first derivative is equal to 0. So those terms must not confuse you. All right. So that is one thing you have to remember before we continue. All right. So what is our word here? It says list area. Okay. We already have the area. So let me write it down. Our surface area is equal to 2x squared plus 800 over x squared. Guys, you need to hold your calculator because this is where we are going to have a problem here. There is no 2 there. What we did previously is supposed to be, how we call it, it's supposed to be 800 over x. Is that correct, learners? Yeah. So it should be 200 over x. So the surface area which we got previously was 2x squared plus 800 over x. This was what we got. Now we are using this one. Now they say we should find the least area. Least is first derivative is equal to 0. So, okay, let me just say I have, I can do it like this as my derivative. I can also say s of a, okay, and put the derivative symbol. It all depends on what you want to do with it. So it doesn't matter how you write it, but ensure that your derivative shows properly. All right, so now let's zoom into action. So we have SA is equal to 2x squared plus 800 over x. Now let's go straight with the derivative. Okay, let me just put it like this, okay, so that you know that I'm doing something, s of x. And this x can also be what? Your a, or whichever way. Okay, let's move on. So let's find the derivative. Power times base, power minus 1. So 2 times 2 is 4. And then we subtract 1 from the power. Then, but what is going to happen, it will be surprising. That if you remember, you cannot find a derivative of a fraction which is in a hyperbolic form. Do you remember? This one, before you find a derivative, it is in positive exponent. You need to convert it to negative exponent before you go on. So when you get to this stage, you ask yourself, what am I going to do? Because you cannot find the derivative of a hyperbolic function unless you convert it into negative exponent. So where do we start from? So you come here. So this is the thinking part of the whole thing. So you say, okay, I need to look at my solution now. Good. So you come here. So you start. You say, well, let me first convert to negative exponent. Well, do you remember how to do that? So we have 2x squared plus, then I would now say 800. We did it in our previous lesson. So those of you who missed the session, you need to go back and watch that video. So now I need to see how I can find the derivative. So let me say this is my derivative. So 2 times 2 will give me 4x. Then negative 1 times 800 will give me negative 800x. But each time you use the power to multiply the base, you must subtract 1 from the power. So minus 1 will give me minus 2. Then before I do anything, I have to convert it back into positive exponent. So I'll then have my derivative to be equal to 4x, then minus 800, okay, all over x to the power of 2. This is where the journey begins. I want you to be patient and understand what is going on. So what we're going to do here is to quickly say, all right, we need space. So let's create space now. How are we going to continue with this version of a question? So let me come here and write this for you. Interesting. So now you have this is equal to 4x minus 4x minus 800 over s squared. Remember, anytime you find a first derivative, what do? You have to equate it to 0. Are you following me? So we are going to equate the whole derivative now to 0. So 4x minus 800 over x squared is equal to 0. All right. So when we have this, you quickly have to solve for x. You know the story. There are many ways of doing it, but the best I can advise you is that take the denominator of this fraction and multiply everything from left to the right. So I will say x squared times 4x squared will give me 4x to the power of 3. Then minus, if I take x squared and multiply 800 over x squared, it will give me 800. Then it will be equal to, if I use x squared and multiply 0, I will get what? 0. Anything times 0 will give us 0. Now, what can we do? We can just group like terms. So let's say we have 4x to the power of 3 is equal to positive 800. Okay, so what can we do? We can now divide both sides by 4. So let me make it clearly so that everyone will understand. So if I divide by 4, then I would also have 800 divided by 4. Your calculator will be better to do this. So it will be x to the power of 3 is equal to 200. Because 4 times 2 is 8. Now, so we have to remove the cube here. So all we have to do is to find the cube root of both sides. We did that in algebra. So x now is equal to the cube root. Okay, don't forget to write your small 3 there. Then I have 200 here. Now, if on your calculator, whatever you do, you should be able to get a value that is close to 5,8, okay, 5,848. All right, now remember one thing. This value here, the x value here, is an x value which we are going to substitute into the original function. If I mean original function, I mean this, whatever we have here. This is called the original function. Now, a learner will ask me a question that said, why is it that we cannot substitute the x into the first derivative? This is our first derivative. So why is it that we cannot substitute our x value into the first derivative? Now, let me tell you something. A derivative is a gradient. So when you take an x value and substitute into a derivative, the answer you are going to get is called gradient. Take note. But when you take an x value and put into the original function, what you are finding is the y coordinate, which can also be determined by any other displacement or the subject of the formula. So take note of that. All right. So what we're going to do now is to take our original formula and then we substitute x into it. Let me see if I can write something here. If I have surface area, all right, so take note of the value. Our value for x is 5,848. We are going to substitute it on our next page for the original formula. So let's say we have x is equal to 5,848. And we know that our formula was the original function, right? Was equal to 2x squared plus 800 over x. Good. So what we are going to do now is to substitute this x value into the formula. Wherever we see x now, we will then put that value. So 2 times 5,848. You close the bracket, but there is a power of 2 there. Then you say plus, then 800, okay, all over x. And our x value is 5,848. All right. So your answer is as good as what you will get on the calculator. Be careful, because if I am not using my calculator here, so I'm trying to use my brain to do my calculation, but you must be able to tell me what you've got. So this is what I accept to be my answer. But you know, we are measuring an area. So an area is measured in a square, okay? When it is a volume, then it is in cube. So take note. So the least area which we can have, or what we also call the minimum area, will be 205,2 centimeters squared. That is for question 1C. Now we will also look at other aspects of the differentiation which we are applying. Let's take a look at cylinder. As you look at this cylinder, it is put in a net form. It is put in a net form, and it is also put in its natural shape, how it should look like. So this is the height. As you can see here, this is the height. You know, every cylinder has a circular face, not because this one is a right cylinder. Remember, it is a right cylinder, so it has a circular face at the top and at the bottom. We have from the center, okay, to the circumference is the radius. And when we extend it, we call it the diameter. Now, when we open the cylinder, it gives us a net. It now looks like a rectangle. But this is not the length of a rectangle, but it is the length of the circular face of the cylinder. So the length of a circular face of a cylinder is called pi d, or what is also known as 2 pi r. So if you haven't seen pi d before, it is the first time you are seeing. Why are we saying that? 2 times radius. Let's say a radius is 4 centimeters. If you multiply it by 2, it gives us what? 8. So the diameter is 8. Now look at it. So 2 times 4 is 8. Now if we replace diameter with 8, it's the same. So that is what you need to look at. And the surface area is equal to 2 pi rh plus 2 pi r squared. Because we have 2 pi r, you see, can you see this 2 pi r? We multiply by the h. You see, the length times the breadth. So the breadth is the height, and the length is what? 2 pi r. So 2 pi r times this will give us 2 pi rh plus the area of a circle. So the area of a circle is what? Pi r squared. But this cylinder has 2 circular faces. This one and this one. So this plus this will give us 2. You see, pi r squared plus pi r squared will give us 2 pi r squared. That is why we have 2 pi r squared here, because we have 2 areas of a circle. Now, so we will have to go to the next section, or the next part of our problem solving, to see how best we can apply the idea in solving these questions. Now, a solid right circular cylinder has base of radius, and then it's in centimeters, and the height is in centimeters. The total surface area of the cylinder is 600 pi. Take note of that, 600 pi centimeters squared. Express the height, or h, in terms of r, in the form of h is equal to 300 over r minus r. Okay, now, so this is what we are going to look at. The information here says we have what? Total surface area here. Okay, So what is the total surface area of a cylinder? Well, we just saw it, right? So let me start with the volume, okay? The volume of a cylinder will be 2 length. What is the length of that cylinder? Are you getting it? So the volume is what? Pi r squared h. So that is the volume of a cylinder. Take note of that. Okay. Another thing I want to show you is that if, for example, we want to make h the subject, we can always make h the subject. So we can have, for example, h is equal to volume divided by all this here, pi r squared. But now I'm just trying to give you an insight as to what we're going to do. But let's start work with what we call the total surface area. And then when we use the total surface area, we see what is going to happen there. All right, let's see the total surface area. So we already know that it is total surface area of a cylinder is equal to 2 pi r h. Is that correct, Lennis? Plus 2 pi r squared. Is that fine? All right. So let's go. Now, but the question is interesting. We've been given the total surface area of the cylinder to be that value. Okay, what must we do? All right, let's see. Let me just put in the values. So my SA will be, let me start from here. It will be 600 is equal to, this time we have to be patient because we are going to be looking at certain things that are very funny. But guys, look, I have 2 here, I have 2 here. So I can make 2 a common factor straight away. I also have pi here. I have pi here. I can also make it a common factor straight away. Okay? I have r here and I have r here. Do I make it a common factor or I should hold on? Okay, but this 600 is not just 600. It's 600 pi. Guys, have you seen that? It's 600 pi. So let me first take out what is common to both sides. Now, I took out the 2 pi. So I'll be left with what? R times h. Then here, I'll be left with r squared. You see, we can always use different methods of doing this. Now, if this is the case, we can divide both sides by 2 pi and see what is going to happen. But I have to do it in the next stage. So 600 pi over 2 is equal to 2 pi into RH plus r squared all over 2 pi again. All right. So this one will divide this one, and then 2 can go into 600. So what will be left will be 300. Is that correct, Lennis? And this pi can divide this pi. So what we'll be left with will be 300 is equal to RH, is that correct? Plus r squared. All right. Let's see what's going to happen. Here again, we have what we call what? A common factor. We have r here, we have r here. So let me take this 300 and say equal to r into bracket h plus another r, because r times r will give us r squared. R times h will give us RH. Now, we can divide both sides, but I don't want to rush things, so I would have to write it again and divide the whole of this by r. Then it's equal to r into h plus r. let us divide all by r. And this r will divide this r. So we will then have 300. We will then have 300, okay, over r is equal to h plus r. Okay, let's see what's going to happen. We are because the question says express h, meaning let h stand alone, but it must be in terms of r. It means we should not replace r with anything. So we must find the inverse operation of addition here. So we are subtracting r from both sides. So from the left side, which is 300 over r, I will subtract r. And then from the right side, I'll subtract r. So r minus r is 0. So I'll then have h. So therefore, our h is equal to 300 over r minus r. I think with this, we can obviously agree that our solution is the same as what we've been asked to prove. And I'm glad that you guys are listening, learners. And if there is any question, you will be able to ask once we are done with all these questions we are working with. Let us now try to see how we can look at another question. Now, this question is based on the previous one. It says, show that the volume of the cylinder is given as V of R is equal to 300 pi R minus pi R cubed. So let's see what exactly our volume is, because the word used here is volume. In the previous question, the word used was surface area. So first, volume of a cylinder. Okay, let me make my V look nicer. Is equal to, what is the volume? It's three things, right? Okay, let's say pi R squared, that is the area of a circle, times height. Okay. And we say again that if we want to do this, we can always say V is equal to, now, pi r squared h must look like this. Yes, this is where we're going to have. If you look at this problem, there is no h. Oh, yeah. And we said in the previous lesson that whenever there is something which is not the same, you need to look for its replica or the substitute. From our previous question, what was our h? Our h, I think it was 300 over r minus r. Okay, so this was what we did in the previous question. Now, this is going to be a lead to our problem solving. All right, so let me say I have pi r squared times h, and my h will be 300 all over r minus r. Okay, let us try to expand the bracket. So our V now is equal to pi r squared times 300 over r. This is the first expansion. Then we use the same thing, we multiply the second one. So it will be minus pi r squared times what? R. Is that correct? Okay. So pi r squared times r is here. Then pi r squared times 300 over this. Now, let me go to the next stage so that it looks nicer. So we have, learners, permit me to show you the primary school method again. R squared will give us r times r. I just want to make it simpler. So this over r, then minus, we already know that r squared times r to the power of 1 will give us r to the power of 3. So we can say pi r to the power of 3. Now, if we divide this r by this r, what we're going to have will be pi r is in the first place, okay, times what? 300, don't panic, I want to make it look beautiful, minus pi r to the power of 3. Now look here now. This is a multiplication, okay? 300 times pi r will give us 300, okay, times pi r minus pi times r to the power of 3. Then this question that the examiner has asked is the same as what we have done. I want you to be patient when you're doing this and make sure that everything is done properly. You need to apply the rules. Well, learners, we are coming closer to the end of the lesson. Let's try the last question here. We have a cylinder which has radius and height, obviously. And then the sum, hey guys, this is another problem. They say the sum of the radius and the height. What is sum? Sum is addition. So I will say r plus h is equal to 2. Now, but I can find h to be 2 minus r. Is that correct? I can also find r to be equal to 2 minus h. Take note of this algebraic equation. Now, the question says find an expression of the volume of what? The cylinder. So before we go anywhere, let me write the volume of a cylinder. Volume of a cylinder is equal to pi r squared h. Okay. Now, so it says find an expression for the volume of the cylinder in terms of r, meaning that we shouldn't have h at all in our solution. Okay. If that is the case, what must we do? Wherever there is h, we must replace it, isn't it? So because we don't want h. So v is equal to pi r squared times h. What is our h? Okay, our h here is 2 minus r. Okay, so volume is equal to, there is an information which we used here. So we are applying that one, isn't it? So pi r squared will multiply this first, which will give us what? Times 2. Then we have, so I can put it in a bracket, you know, the distributive property. Then we take this one again, we multiply this. So what shall we have? We shall then have pi r squared times what? R. Okay. So what's going to happen? Let's see quickly. We don't have much time. We're going to have what? This time this will give us what? 2 pi r squared. Is that correct? Then we have minus pi r to the power of 3. So now it continues to say we should, that is first, you should express the volume, right? Okay, but it says something which is very intriguing. It says find the maximum volume. Okay, what is maximum? What is maximum? Maximum means what? Okay, you remember I said maximum means what? First derivative is equal to 0. So we say 2 times 2 is 4. Then we have pi r. Then 3 times pi will give us minus 3 pi r to the power of 2. Okay, but it must be equal to 0. So our first derivative must be equal to 0. So we can have 4 pi r minus 3 pi r squared is equal to 0. Okay, so what are we going to do? We need to first solve quickly for r, isn't it? All right, so let's take out the common factor. I can say in this problem, I have r, let me take out, okay, pi, let me take pi first, and then I have what? 4r minus 3 r squared equal to 0. Okay, so we divide both sides by r. Obviously, learners, you know that one. We will be left with 4r, okay, minus 3 r to the power of 2, okay, is equal to 0. The next thing we have to do is to take out whatever we want to do. We can say r into 4 minus 3 times r, okay, is equal to 0. Then this is a product method. So r is equal to 0 first, or, okay, 4 minus 3r is equal to 0. So obviously r is equal to 0. So here we will then have, you know that very well, to be this 4 will become negative. Negative divided by negative is positive. So we'll then have 4 over 3. But the problem now is that you are to substitute this r, you know, into the actual value, okay, of the surface area. So you are going to, let's take the volume. What is our volume? Our V is equal to pi. So our pi into our value will be 4 over 3. Please put this thing on the calculator for me so that you can give me the final answer. Learners, 2 minus 4 over 3. Now, so if you calculate this, you see that there will be a number left with a pi. So our value should be 32, if I'm not mistaken, 32 pi all over 27. This is 2, okay? This is not z or the letter z. But because it is a cube, we are having it in a power of 3. So learners, this brings us to the end of the lesson. Just look carefully at the solution and you know what to do. Thank you very much for being part of this program. And I believe that you have enjoyed the lesson. And thank you very much for coming. And my lesson is over. Thank you.
Thank you, Mr. Victor. That was indeed a very great session. Participants, if you have any questions, kindly post it in the chat box so that Mr. Victor will be able to answer them.
Yes, learners, so that is the challenge thrown to you. That is a challenge thrown to you. Let's see if there is any question in the chat box. Right now, there is no question in the chat box.
Yeah.
I think we can end the meeting. And then when learners have follow-up questions, they can always email us and we attend to them. Thank you very much.
Before ending up the session, I would like to ask the participants to take up the poll.
Okay.
Take up the poll before ending the session.
All right. So participants, the challenge is up to you. You do your poll. You can rate it. 1 means poor, 2 is satisfactory, 3 is good, 4 is very good, and 5 obviously should be excellent. How do you rate the session? Number 2, how do you rate the content and delivery? 1 is poor, 2 is satisfactory, 3 is good, 4 is very good, and 5 is excellent. Try to move your finger and go on the number and click.
Yeah, the participants are taking up the poll. Thank you so much, Mr. Victor, once again for sharing your time and knowledge.
Thank you very, very much, and we will be glad to continue this, especially as it's been very interactive, and I wouldn't hesitate to speak on the next program. Thank you.
Thank you so much, Victor. Thank you.